All right, let's jump into lesson 12:1. A circle is just a set of points in a plane that are a given distance from a point in the plane. Now, a circle is not a polygon, right? And so you're always going to have a center point, and every circle is named by the center point. So technically, this is circle O, and I really don't like the O, so let's turn this into a P. So the way you would write this is you would put a circle with a dot in it, if my pen will work, and then a P next to it. There's a dot in the middle. And you put the dot in the middle so it doesn't just look like a zero or an O. That is like the symbol for a circle. Okay, so we all know this. This is going to be the same length as this. This is called your radius. Okay, and here's your formal definition of a radius. It's a segment that connects the center of the circle to any point on it. And the corollary to the definition of a circle is that all radii of a circle are equal, which we will use that within proofs. And we all know that if it's a real circle and not like an oval, um, all the radii will be the same. And the word radii is the plural form of the word radius. All right, concentric circles. Now, they do not have to be pretty colors like this one. Usually they're just all like little black circles. They all have, well, first of all, they're in the same plane, so they are two-dimensional, and they have the same center point. So, do concentric circles have the same radius? And the answer is no, because this red circle, the radius is very small, but let's say like this green one, it's bigger. And as you can see, the radius will all change depending on which circle it is. So, again, the definition is they lie in the same plane, and that's a D, and they have the same center. Okay, so now more vocabulary. A chord is a line segment that has both endpoints on the circle. Okay, so this is a chord. There's an endpoint and there's an endpoint, and that's on the circle, and they are connected. So technically, your diameter is a chord, but it goes through the center. And let's read the definition. It says of a circle is the chord that contains the center. Okay, now is a radius a chord? And the radius is not, because it only has one endpoint on the circle. The other one is at the center. So a radius is not a chord. Theorem 56. If a line through the center of a circle is perpendicular to the chord, then it also bisects it. So we have to look and see what it says first. A line through the center, okay, so we're talking about right here, and it's perpendicular, then it's also bisects. Okay, so these get really confusing, but on this one, you have to know that it's perpendicular first, then it bisects. So perpendicular, then bisects, and that's theorem 56. Theorem 57 says if a line through the center of the circle bisects, and it's not the diameter, then it also perpendicular to the chord. Okay, so this is like the converse of it. So they're saying if this bisects, then it's not going through the center, okay, then it has to be perpendicular. So this one says if it bisects, then it is perpendicular. So that's the difference. Here, I'll circle these keywords. So on your theorem sheet, I would circle those keywords or even put this shorthand on your theorem sheet to help you realize what's happening, because one is the converse of the other. Theorem 58. The perpendicular bisector of a chord of the circle contains the center of the circle. Okay, so a perpendicular bisector comes straight down and it makes a right angle. Okay, so whenever you have that, it's saying that it will always contain the center point. All right, so in circle F, and we know it's circle F because you name it by the center point, and technically I didn't have the symbol, but you could write it like this. AB is bisected by D, so CE